Unbelly Airball, Jupiter will swallow Earth. A stunning new image of Jupiter's tumultuous Great Red Spot has revealed what it might be like to glimpse the biggest storm in our solar system up close. The image shows a natural color rendition of the massive storm, based on data from the Juno spacecraft's 7th close flyby of the planet, simulating how it would be seen by the human eye. Juno captured the view from about 8,648 miles (13,917 kilometers) above the cloud tops using its Junocam imager. During these flybys, Juno is probing beneath the obscuring cloud cover of Jupiter and studying its auroras to learn more about the planet's origins, structure, atmosphere and magnetosphere. Early results from NASA's Juno mission portray the largest planet in our solar system as a turbulent world, with an intriguingly complex interior structure, energetic polar aurora, and huge polar cyclones. The image of a crescent Jupiter and the iconic Great Red Spot was created by citizen scientist Roman Kakenko using data from Juno's Junocam instrument, NASA said. The $1.1 billion Juno mission launched in August 2011 and arrived in orbit around Jupiter on July 4, 2016. The probe is zooming around the huge planet on a highly elliptical path, making close approaches, or perijoves, once every 53.5 days. Juno is investigating Jupiter's composition and interior structure, with the aim of helping scientists better understand the gas giant's formation and evolution. The probe collects most of its data during perijove passes like the July 10th event, 7 of which it has completed so far, not counting the initial one on July 4th of last year, when Juno's science gear was turned off. Juno's mission is scheduled to last until at least February 2018. The Great Red Spot has been raging for centuries. The huge storm is about 10,000 miles (16,000 kilometers) wide, meaning it's bigger than the entire Earth. However, it used to be even bigger. The Great Red Spot has long been shrinking, for reasons that scientists don't entirely understand.
My name is David Choi, and I study the weather on giant planets. When we look at Jupiter, we're seeing the top of its atmosphere and its weather layer. And its weather layer contains a lot of interesting features such as jet streams, vortices, storms, and these particular features called hotspots. So hotspots are like holes in the clouds because they appear very dark when observed in visible light, but in near-infrared light they appear very bright. This indicates that we're seeing deeper down into warmer layers of the atmosphere. Hotspots have been previously studied by the Galileo Atmospheric Probe. In 1995, the spacecraft released a probe that descended into Jupiter's atmosphere, specifically at a hotspot. And this probe made the first in-situ measurements and the only in-situ measurements of Jupiter that exist today. So it's very important to understand how hotspot meteorology works in order to place these in-situ measurements from the Galileo probe in its proper context. In 2000, the Cassini spacecraft flew past Jupiter and created a series of still images that we compiled into time-lapse movies of Jupiter's atmosphere. Using these movies, we observed Rossby waves that caused north-south meanders in a jet stream south of the equator. With new movies, we instead focused on hotspots. Hotspots are unique because we believe that there is a Rossby wave similar to what we previously detected, but instead of this Rossby wave moving north-south, it primarily moves up and down in the atmosphere. The downward portion of the wave pushes air down into warmer layers of the atmosphere. This causes any clouds that are embedded within the wave to evaporate and prevents further clouds from forming. So at any given time, there are approximately 8 to 10 hotspots in Jupiter's atmosphere that are spaced roughly evenly apart from one another. We believe that each of the downward portions of this Rossby wave corresponds to the hotspots that we see on Jupiter. This new finding is exciting because it'll allow us to re-examine the Galileo probe data and allow us to better understand it and better place it in the context of Jupiter's overall global climate and atmosphere.
Forecasters are issuing an urgent hurricane warning. The details are frightening. Winds will top 400 miles per hour. The storm is 16,000 miles across. It will last for centuries. The good news, no cities are in danger because this storm is on the planet Jupiter.
Jupiter's Great Red Spot is more than a Category 20 hurricane.
It's 500 million miles away, but we can't help wondering what it would be like on Earth.
A storm on Earth with the intensity of the Great Red Spot would be truly devastating.
The water would pile up and would be several hundred feet deep.
And it would move on a storm track so slow, it would seem to last forever.
The storm would be there for a long, long time. It would not be a fun place to be.
Watch out. It's space weather at its worst. The biggest storm in the solar system. Earth's is just one kind of weather. On other planets, there are storms beyond the imagination, climates and conditions that we hope to never see on Earth. But could they happen here? And if so, could we survive?